And I'll start from the very basic elementary, but then bow down directly to the application part of this, which encompasses a lot of ongoing work which I am presently doing and which I have done with my master's and PhD students as well. So when it comes to machine learning, how we plan it, how we see it, the broader term, when we talk about the machine learning and the deep learning, the broader term is intelligence. So the intelligence comes like the capacity to learn and solve the problem. When the machines attain the capacity to learn and solve the problem, we call it intelligence. And when it comes to what is artificial intelligence, it is a simulation of human intelligence by machines, the ability to solve problems, the ability to act rationally like the humans do, and certainly the ability to act like human beings. Learning is any process by which a system improves performance from experience. In this context, I would like to take the example of the YouTube. Like whatever the things we keep on doing, keep on looking, keep on looking. If we keep on looking at sad songs, the next time when I visit YouTube, it gives me the advice or suggestions related to the sad songs only. If I look the Kishore Kumar songs, certainly next time it will approach me by suggesting the songs sung by the particular singer or the Kishore Kumar as well. So this is how the machine, a system, keeps on learning from the past experiences. So a famous definition by Tom Mitchell, which I have used in many of my research papers, like there is a task T with experience C, the performance P is improved. So this is probably the tuple which we look after. This is a bigger idea. Artificial intelligence, like the ongoing things, as we talk about the chat GPT, it falls under this, I mean, everything falls under this category. The broader term artificial intelligence, the computer with the ability to reason as humans. Machine learning, when it comes to machine learning, it is the ability to learn. Computers with the ability to learn. And deep learning is the very narrow subset of it, with a network capable of adapting itself to new data. This is what the basic difference between the traditional programming and the machine learning. In traditional programming, let us say when we are talking about write a program for C or something like that, what is the input? The input is the data and the program, and the output, and we comes up with the output. Like if the program is to sum two numbers, add two numbers, or whatever, print a mark sheet, take out the percentage, it comes out with the output. But with the machine learning, it's certainly somewhat opposite. We have the data and the output as well. And what the computer generates? Computer generates the program, which program or the hypothesis, which is most of the time used to, take the decisions in the near future. Okay. What are the examples which are best suited for learning algorithm? See, obviously recognizing patterns, facial identities, which is this particular term is related with what we can call with the students. When the students are there in the class and we don't want to waste time and take the attendance. So facial identity, the facial expressions, many applications are taken, like the students enjoying the class or feeling bored of it with the help of facial expressions, handwritten or spoken words, medical images, medical image registration, medical image fusion are the example of it. Generating patterns, images or motion sequences, recognizing anomalies, unusual credit card transaction. Someone is actually doing transaction of 100 rupees or 500 rupees and all of a sudden making a transaction of lakh, which is an anomaly, right? Use unusual patterns of sensor readings in a nuclear power plant. Prediction, stock price prediction is one of the the most common, most normal, known example of it. And when it falls under the category, what types of learning we are talking about? There's a supervised learning, unsupervised learning, semi-supervised learning, and reinforcement learning is there. Okay, so when we talk about supervised learning, so what is the thing we have? We have the training data plus the desired outputs or labels. So we are going to see it in the coming slides. But what is it is actually? Like we have whatever the output we have. Okay, we have labeled data. We have every data we have, it is labeled. Okay. Training data means the data which will be used to train the model. The model, the function, the hypothesis. These all are the three terms which is actually representing the one thing which is used to for use to predict or classify the unknown data. Okay, and then there is an unsupervised learning. Unsupervised learning is we don't have the desired outputs. We don't have the crystal clear desired, I mean the labeled data. The third category is semi-supervised, means a mixture of supervised and unsupervised. We have the training data. Some data outputs are there which are labeled, but the some are not. Reinforcement learning, rewards from sequence of actions. Each and every action build the model. Like now, when I'm actually opening my Amazon account, it knows for what things I search for. It keep on advising me the similarly from the past history or the search history. Every action in the past leads to further. So when it comes to supervised, the basic very first category, supervised versus unsupervised learning. Supervised learning, and see, I mean, whatever we do, it falls under the two category. There is a regression problem and the classification problem. Okay, so first of all, let us look at it in the context of classification problem. The training data observations measurement. Training data, when it talks about training data, the training data means the data which will be used to train the model, to build the model initially. The training data, observations, measurement, etc. are combined by labels indicating the class of observation. And then comes the new data, which is classified based on the training set. Unsupervised learning, now the clustering comes into the action. The data is not labeled. So in this case, we need clustering. The class labels of training data is perfectly unknown. Given a set of measurement, observations, etc., with the aim of establishing the existing of classes or clusters in the data. See, this is how the problem can be looked at. And so this is a classification, and the regression problem can be broadly viewed. Okay, classify images into different classes. What we can say, we have a breast cancer detection. Okay, so there is a tumor. Now the tumor is a cancer or not? See, okay, it's a classification problem. The tumor, yes, it's a cancer. No, it's not a cancer. So yes and no. It's a classification problem. It's a binary classification, but at the end of the day, it's a classification problem, which can be viewed perfectly in the very first figure. Okay, so this is how this line, what we can see, this is the line, this is the model, this is the function, this is the hypothesis, or we can say which actually classifies in the two categories. We have an image, breast image, which actually classified into. Now the next comes the regression. The regression, the basic example, very basic example is there. House price is a house price prediction based on feature of house. So what is the feature we have taken? The feature which we have taken is the size of the house. Size of the house. Okay. 1,000 square feet, 2,000 square feet, 3,000 square feet, 4,000, and the 5,000 goes on. The house prices keep on increasing. There can be certain other factors, the locality and other factors as well, the place we are looking for. Okay, but we have right now took one feature. So as soon as the size increases, the price increases. And this is the model which is actually predicting the same. This is how broadly the regression and classification problem looks like. Now let us deep dive into this idea. Let us suppose this I have this data x1 y1. This is the training data, friends. X1 y1, these are the two labels, x1 y1, x2 y2, and similarly goes for x and y. So what is the x in this case? See, x in this case is the, what to say, is the year 1970, 80, 90, 2000, 10 years in different. What is the y? The y is I sextant, architect C I sextant. Okay, so in particular, in what year the I sextant would what? Okay, learning a function fx to predict y given x. So this is what we have it. Okay, y is a real valued function. So when y is a real valued function, we falls into the category of what to say, the regression. Okay. Now, I mean, this was the broader, this was a deep dive into the regression idea. Now we are Getting next to classification, supervised learning classification. We have given x1, y1. Now, what is x1 in this category? See, x1 means the tumor size. Now, this is a perfect, we are looking at the example of, in terms of classification, in context of classification, we are looking about the breast cancer actually. So the cancer, the tumor, which we come across while analyzing or detecting the disease, whether the tumor is malignant or benign. Okay. So it's a binary classification, whether the tumor is benign or malignant. Now, depending upon the tumor size, what we are going to do, we are learning a function fx to predict y. Y means whether it is malignant, it's a 0 or a 1. Okay, given x. What is x? X is the size of the tumor. Y is categorical. That's why we are saying that it's a classification problem. Okay, breast cancer. Okay, now depending upon the tumor size, if the tumor size is beyond a certain limit, we call it malignant. Otherwise, it's a benign. Right. So this is what the classification problem looks like. Now, now we can also see the x. X means this. The x is the tumor size. So whether the tumor is malignant or not, 0 or 1, depending upon the tumor size. But this x could be multidimensional as well. I mean, depends upon, I mean, more than one attribute. In that case, x can be multidimensional. Each dimension corresponds to an attribute. Each dimension corresponds to an attribute. Okay. So the tumor size is certainly a factor. Age is another factor. Okay. Clump thickness, uniformity of cell size, I mean, a lot of factors could be there. Then we call it a multidimensional. Okay. See, the next is given x1, x2, xn without labels. Okay. And output is hidden. We don't know the output. We don't know what is the output. Okay. We just have the x. We just have the x. We don't have the output. In that case, what we have to do, based on the similar characteristics, we have to cluster the x or the input data. Okay. So that's what the clustering comes into the action. So the clustering only comes into the action when there is an unsupervised learning, or when there is an unsupervised learning. Okay. When there is a labeling, we don't need that. But when there is no labeling, okay, we have to make clusters because the output is not defined in that case. I mean, a similar example of this is we have this sample which is further categorized, clustered, dividing the population into groups. Same group members resemble each other compared to other groups. So there are a lot of that. I will present a lot of applications which where, I mean, the clustering is ensembled with a deep learning technique in order to achieve aim, right? K means hierarchical KNN, PCA. This is what it is. So these are the applications actually where unsupervised learning is mostly applied. Okay, so this is the market segmentation. Market segmentation, how the markets are segmented. See, there can be, I mean, what you can see, the large cap companies are there, the mid cap companies are there, the small cap companies are there. See, the cap, I mean, those who are fond of stock market, they might be very well aware of this term. That large cap means, I mean, then they have invested in the market 1500 crores and plus. So these companies are different. They're in the ultra cap, like Reliance is there, and many companies are there, Tata, Reliance. So they comes under the category of large cap broadly. Okay, there are companies which have 10 years or 15 years they have actually covered successfully, okay, among the public. So they could be in the mid cap, and those who have just started, they can be in the small cap. So this is how the market could be segmented. Organizing clusters, social network analysis. So here you can see the pattern, like there's the social network analysis, the group of people, those who are close friends. Like if we talk about this maroon people, they all are friends with each other. But like maroon is not friend with this green guy or many green guy. There are only one connection. This is how this clustering, or we can say unsupervised learning, have a very application. I mean, a lot of application in social network analysis. When we talk about social network analysis, it falls under many categories. Like we know that we often receive the mail that does this author have this publication. So how they actually do? They actually detect a paper in which you and me could be a common author in a paper, and then they figure out a paper in which someone else, someone X, Dr. X has this that paper. So they might want me to authorize the same. This is how they usually do it. Okay, and based on the basis of that, they find out connections among people. When we have a link, they, I mean, the attributes is you might have done this degree or that degree from the same college. You might be knowing each other. The friends or the friend of friends. This is how the social network, every social network grows. The Facebook goes with you have a common friend. But LinkedIn have it different perspective. You might have did the same this degree or might have worked in the same duration in a same college. Astronomical data analysis. I've been working with social network analysis where I'm actually finding the missing links. Okay, using the same DL and ML techniques. Okay, there's an association rule based learning. This is what we know it very well when we are going to purchase something. So there could be something item set. Like this is an anecdote, friends, where we have actually purchased something: bread, milk, bread, diapers, beer, eggs. So these diapers and beers, they often appear frequently together. So when I mean, we could say that when one goes for this, they goes for this as well. Discover rules that describe large portions of your data. Product placements in mall. People that buy X also tend to buy Y. Okay, now let us take a idea about the prediction problems. The prediction problem, the classification versus the numeric prediction. Classification predicts categorical class labels. It classifies data, constructs a model, basically what we often call, I mean, different people call it different ways. Some call it a function, some call it a hypothesis, and better it is known as a model based on the training set and the values, class labels in a classifying attribute used in classifying new data. Numeric prediction means model continuous valued function that is predicts unknown values. The applications are credit loan approval, medical diagnosis, if a tumor is cancerous or benign, fraud detection, web page categorization, which category it is. And I mean, web page categorization. So we used spam blocker or something. It is the most common example of this web page categorization. And when we comes across classification, it's a two-step process. The first step is certainly the model construction, describing a set of predetermined classes from the training set. Each tuple sample is assumed to belong to a whatever tuple means the training set there might be 10 or 8 tuples. So I mean 80% of we use data in the training set. So each tuple sample is assumed to belong to a predefined class as determined by the class label attribute because the data is labeled. The set of tuples used for model construction is training set. The model is represented, no, the model which we have created is represented as a classification rule decision. We are going to see in a broader idea. In a deep, we will take a deep dive into it or the mathematical formula. Model usage for classifying future or unknown objects. We estimate accuracy of the model. Okay, and there are many parameters on based on which the accuracy is estimated. F1 score, sensitivity, and a lot of things. Accuracy rate is the percentage of the test samples that are correctly classified by the model. Now, the test set is independent of the training set. Okay, if the accuracy is acceptable, use the model to classify new data. So let us have an example of this. Let us see that there are name of the faculties: Mike, Mary, Bill, Jim, Dave, Anne, and there is a rank: assistant professor, professor, associate professor, and the years for which they have served in an organization. Let's say now this is what we can say a classification problem is there. See, these are the faculty's name, their designation, and the years they have served. Now, whether they are tenured or not, that's the problem. or we can take it in, for the sake of simplicity, we can consider that uh, whether these people or these faculties who have been working so far are, what to say this, is regular or not. So as we can see, as we can analyze the data, that he has been serving for 3 years and not tenured as a designation of assistant professor. For the 7 years, yes, he's tenured. He is a professor with 2 years, but tenured. Associate professor for 7 years, yes, tenured. Assistant professor 6 years, not tenured. Associate professor for three, not. So what could be the function or the model or the hypothesis which could become is, if the rank is professor or years is greater than 6, then tenured years. Otherwise, no. This is how basically the classification problems, the model, the classifier model is generated based on the training set of data. Now, based on this, this is the testing. Sorry, unseen data. We have we have the, like, the testing is done. So 2 years, not tenured. Associate professor 7, no. So this is a false case, guys. This is a false case. George, he's a professor, yes, tenured. Joseph, he's a 7 years, tenured. But this is the wrong case in this. Now we can actually figure out the accuracy from this, that one is the case in which the model has failed. This should be yes. Okay, but not. Okay, rest are the cases. We are done. We are predicting correctly. So this is how we figure out the accuracy. Now there is the last segment of it, reinforcement learning. Given a sequence of states and actions when with delayed rewards, outputs a policy. Policy is a mapping from state to actions that tells you what to do in a given state. Credit assignment problems, game playing. So this is what you can see. We have an agent and we have an environment. The agent plays the action 80, which goes in the environment, and the environment what have the next state and the reward as well. Agent and environment interact at discrete steps. Uh, okay, so let us have an example of this. Mm, just to wait, I'll give the example. Agent and environment interact at discrete time steps 0, 1, 2. Agent observe. Agent, what does the agent do? It just observe the state, whatever the state is coming. Okay, get resulting about, gets resulting about, and resulting next state as well. Okay, this is how the things goes on. This is called reinforcement learning. Whatever the action is done, okay, agent gives to the environment. Based on that, we have the state and the reward as well. So I mean, whatever the machine learning process we have went through, okay, we can see that this actually falls under this category. First of all, what we do, we actually gather data as accurate as it can be, it will be. Now what we do, we actually, there is a section where the gathered data, I mean, noise is removed from them, a lot of things. I mean, I will show the applications in which it can be viewed, that what are the amalgamations, or we can say the transformations have been accomplished on the data to make it clear and crystal clear, which could be used for the model creation. So next here, broadly, if we talk about, we have the data preparation. Data is split into two parts for training and evaluating. What we do, and then we choose a model corresponding to the data type. Repeating process of adapting data, that is called training. And testing model on unused data. See, broadly, the data we have is actually divided into two parts, the training part and the testing part, 70, 30. This is how it is. On the training part, the data is, the model is trained. On the training part, whatever the tuples we have, 70% of the tuples we have is used to build the model, while 30% is used to test, okay, based on which we comes out with the accuracy, as we have seen in this example. Again, this was a training and this was a testing data. Whatever the model we have, the classifier we have, because we have used this in context of classifying, right? Whether the candidate is tenured or not. Okay, so I mean, these are all the applications which we have seen. Healthcare, high infant mortality rates in India. Okay. When we talk about infants, the children, those who are premature born or just born, okay, the condition of the children, those who are dying, is pretty high in India. Lack of access to quality healthcare. Develop a comprehensive system for real-time data collection, analysis, and data making. I mean, the guy you can see on the screen right now is me. I, the person you can see on the screen is me itself. Okay, I mean, a team of students, a lot of team of students, along with me, we were a part of a project which we have recently put it in a patent, and we are in the process of writing multiple papers on that. Actually, a lot of things on it. This is the half attire I have on. Actually, a similar knack was. Uh, this is our library room. So I have booked a room, and actually we have conducted this experiment. A lot of things went on. We were actually taking the readings of movement, hand movement, and the chest movement. We were actually collecting this data. That so as you can see, this is the real-time data collection, and whatever have been collected, friends, whatever we have collected, what while movement. When I was moving, I mean the readings through these wires fed into the system, a model which actually generates the training score, and which is further used to build this explainable AI. So this is an and combined which we have actually used. Okay, I can't speak more about it because we have actually, but I want to actually tell them how the amalgamation of IoT devices. See, these are the Arduino boards. Okay, and which are actually collecting the movement. The sensor is actually dedicated towards collecting the movement. Fine. Let me tell you one thing very clearly, that altogether 56 features from all these and one to the next. 56 features have been collected, which are fed into the system, executing on this laptop, which is, and the output of that model is actually given to another explainable AI model, which results can be very well seen on the screen. So I mean, broadly, if we talk about, there are data sources. Like in this case, what is the data source? This, and one more to the next. These are the data sources. ये जो इस वक्त आप अपने कंप्यूटर स्क्रीन पर देख रहे हैं, ये मेरे ही थर्ड ईयर के और फाइनल ईयर के स्टूडेंट्स थे. मतलब इट्स अ टीम ऑफ 5 स्टूडेंट जिसके साथ हमने एक्सपेरिमेंट कंडक्ट किया था. इट वाज अ एंटायर डे एक्टिविटी जिससे हमने ये कंडक्ट किया था. इट्स अ हेल्थ केयर एनालिसिस बेसिकली. तो इसको आप इससे एसोसिएट कर सकते हैं. दिस इज डेटा सोर्स जिससे हम रियल टाइम डेटा कलेक्ट करते हैं और वो डेटा जो है डाला जाता है. And a various models are there which actually predicts or classifies depending upon the problem. Okay, link prediction. It is a, I mean, the link prediction is not just limited. I'm actually expressing the applications. The link prediction is not just limited to finding the missing links. It aims to present the probability of link formation between nodes. See, whatever the social network they are there, whether what we can say, we can talk about the LinkedIn, the Facebook, the Instagram, the YouTube. These all are the basically social networks, and it grows. It depends. There are, I mean, upon the number of users have made their accounts. Okay, depending upon the number of candidates present on the social media grows. Okay, so how they will grow? When they can actually let you know that your friends are there. Certainly, the friendship grows, the network grows. To predict the formation of links between unconnected nodes in a graph based on various metrics and network characteristics. This is what it is. So, I mean, this is the missing candidate, which they all figured it out. They are the friend of friend, and they soon tell them. Let's suppose that this guy has made a new account. So, what he will get? He will certainly get the news about them, that your friends are over there, or the friends of friends are over there. Link prediction and its application. So social networks, first of all, link prediction is used like for recommending friends Similarly, on Facebook, Insta, predicting future connections, enhancing collaborative filtering in a recommender system, and identifying potential collaborations. Knowledge management. These techniques are used in knowledge management system to forecast changes in network structures, facilitating better decision making process and knowledge dissemination within organization. Certainly, security analysis to identify hidden relationship between individuals or groups, which even helps us to predict potential criminal activities and enhancing security measures. In biology and network biology, academic social networks, the LinkedIn and the uh, via co-authorship, which I have already discussed, I guess. Okay, for recommending potential collaborators among researchers based on co-authorship networks and predicting future collaboration. So this is what we can see. So broadly, whatever the techniques which we have went through, guys, can be actually used to for acting machines as a humans. So Sophia is one of the good example of it. It's a social humanoid robot developed by Hong Kong-based company Hanson Robotics. It actually behaves like humans, the way it talks. Okay. So now, whatever the things we have seen, whatever the things we have seen, I want to take it to a level of application with the cloud computing. Whatever we have seen, like the regression, the classification, whatever we have seen, we are looking towards the application part of it. So when we talk about cloud computing, we will, in the coming slides, we will see what is the role of deep learning techniques or as we know that IoT when join hands. I mean, when the Internet of Things, when we used to collect data from Internet of Things, um, at the real time, and when it join hands with machine learning or deep learning based techniques, the output can be very helpful to the medical practitioners and the patients as well. Okay, this is how the idea goes on. But what in terms of cloud? I mean, think speak is one aspect of it. That whatever the data is collected and transferred to the think speak, fetched and given as input to the model. This is in one aspect of it. But let us try to see what could be the role in cloud computing. How cloud computing could be benefited by the usage of deep learning and machine learning techniques. What are the challenges in cloud computing for which these type of techniques could be pretty much helpful. So just a minute, just give me a minute. So try to, am I audible?
Yes, sir. Audible.
Okay, thank you. Okay, so try to understand the underlying challenges and the problems with which the cloud computing might be going on. Let us understand the importance of cloud computing in our life. See, uh, from the morning when we wake up, from Gmail to WhatsApp to Insta to Facebook, each and everything, for each and everything, we are interrelated. We are somewhere dependent on the cloud. I should not use the term connected with the cloud. The thing is that we are dependent on the cloud. The cloud computing is a necessary aspect of our life. Cloud computing, what is this? Cloud computing is a use of computing resources that are delivered as a service over a network. Okay, see, when we talk about computer, what are the services a computer can provide? It can provide the storage where the data can be stored, the processing of that storage. Okay, for this the CPU is there, and any application. There are three, which is furthermore categorized as infrastructure, platform, and software. Well, we are not moving in that direction, but I want to tell that cloud computing is an important aspect of our social and academic lives. We can't get rid of that. Certainly, there are a lot of benefits. Benefits is the only thing which attracts us a lot of people towards cloud. Otherwise, there is no point of using that. Certainly, the one is pay per use basis. See, if there is no benefit, we as a human being are not bound to move towards the cloud. And if we are not bound to move over towards the cloud, then there is no point of solving the challenges with the help of DL or ML or whatsoever. There are a lot of benefits. And in the aspect of achieving or get benefited from that benefit, we move towards the cloud. We have to just pay whatever we are using. That is the first benefit, and that falls under the category of pay per use basis. The next is capex model to opex model. From capex model to opex model, the capex model is it can be very well understood with the help of an example. Let us suppose there is a person who used to do photocopy. There is a candidate जो photocopy करता है. अब हम जब photocopy कराने जाते हैं तो we are charged on एक पेज का ₹1, right? He is get paid for that. उसने 10 पेज निकाले, but down the line उस एक पेज को उसे निकालने के लिए उसे एक दुकान लेनी पड़ी, एक मशीन लेनी पड़ी फोटोकॉपी. तो वो मशीन पे जितना खर्चा हुआ फोटोकॉपी की, वो होता है कैपिटल एक्सपेंडिचर. और वो पेज पर जो खर्चा हुआ जिसके बदले में उसे मुझसे पैसे मिल जाएंगे, दैट इज ऑपरेशनल एक्सपेंडिचर. तो क्लाउड की मदद से हर बिजनेस कैपेक्स मॉडल से ओपेक्स मॉडल की तरफ ट्रांसफर हो जाता है. दिस इज वन ऑफ द वेरी वेरी ग्रेट बेनिफिट. Certainly the performance enhances this. Okay, for security I'm not dependent. अगर एक बार मैं किसी की क्लाउड सर्विसेज लेता हूं, I can pay him, but he is the person who is responsible for security. Certainly we have a good speed and the reliability. There are service level agreements are there जिसके अंडर ये security, speed, reliability आती है whenever I'm going to take the benefit of any cloud services. Okay, now with the notion of enjoying these benefits, let us try to understand some basic things which will be helpful for me. The very first term which comes in the cloud computing is the virtual machine. What is virtual machine? VM is a virtual environment that functions as a virtual computer with its own resources created on a physical hardware system. So what we can see, like on this side where my cursor is moving, it's a physical device which have a long chunk of processor, RAM, ROM, network. Now, this is a physical device in actual. This physical device can be virtually divided into virtual machine 1, 2, 3, 4, 5. Underlying it is having the same hardware, but on the top of this, we have maintained 5 virtual machines. These are the guests. If I comes, my application can be mounted on VM 1, 2, 3, or any. Now these VMs are monitored by hypervisor. These are, whenever we talk about cloud, there are 2 to 3 terms pretty much important. The one is hypervisor, virtual machine, and virtualization. As simple as that. Now these are the challenges. The first and cloud services deals with several challenges in order to provide cloud services to users. Energy consumption, ये सबसे एक इंपॉर्टेंट एनर्जी कंजम्पशन मैनेजमेंट. एक क्लाउड डेटा सेंटर में सबसे इंपॉर्टेंट जो चैलेंज आता है वो होता है एनर्जी कंजम्पशन. ये एक सबसे इंपॉर्टेंट है. क्लाउड डेटा सेंटर की कंडीशंस ये है कि हमारी जैसे इंडियन गवर्नमेंट ने भी कहा है कि जो डेटा है इंडियंस का वो बाहर के क्लाउड डेटा सेंटर्स पे जाके स्टोर नहीं होगा. जैसे अमेजन का मुंबई में डेटा सेंटर है। भारत में 1 से 2 डेटा सेंटर है, जिसमें से अमेजन का मुंबई में एक डेटा सेंटर है। लेकिन बाहर की कंपनीज के पास डेटा नहीं जाएगा। तो नाउ द डेटा सेंटर्स आर एक्चुअली कमिंग विथ लॉट ऑफ स्पेस। पंचकुला में अनंतराज करके जैसे एक डेटा सेंटर खुला है नया। पर ये क्लाउड डेटा सेंटर्स जो होते हैं, ये काफी चैलेंजेस फेस करते हैं। ये क्या चैलेंजेस फेस कर रहे होते हैं? इनकी सबसे इंपॉर्टेंट होता है एनर्जी कंजम्पशन। एनर्जी कंजम्पशन क्या जाता है? इनके कूलिंग एंड प्रोविजन सिस्टम 43% जो एनर्जी है इसमें चली जाती है। स्टोरेज ड्राइव्स जो है 11%, नेटवर्क 3% और सर्वर 43। मतलब दिस इज व्हाट द एंटायर रफ आइडिया इज। इफेक्टिव रिसोर्स यूटिलाइजेशन। ये सबसे बड़ा एक इंपॉर्टेंट एक फैक्टर है। देयर कैन बी लॉट ऑफ फैक्टर्स बट द इंपॉर्टेंट इज एनर्जी कंजम्पशन मैनेजमेंट। इफेक्टिव रिसोर्स यूटिलाइजेशन। अगर रिसोर्स का यूटिलाइजेशन इफेक्टिवली होगा तो एनर्जी भी जो है वो ऑप्टिमाइज हो जाएगी, एनर्जी कंजम्पशन भी ऑप्टिमाइज हो जाएगा अगर रिसोर्स का यूटिलाइजेशन इफेक्टिव होगा। डिटेक्ट करना हॉटस्पॉट और कोल्ड स्पॉट। देखिए, हॉटस्पॉट और कोल्ड स्पॉट होते क्या है? ये सारी रिसर्च प्रॉब्लम्स है जो मैं आपके सामने इस वक्त रखा हूं। हॉटस्पॉट मतलब कि किसी सर्वर पर 90% से ज्यादा अगर लोड चल रहा है तो वो हॉटस्पॉट में आ जाएगा। और 30% से अगर किसी के पास कम लोड है और वो मशीन चालू है तो वो कोल्ड स्पॉट में आ जाएगा। लोड बैलेंसिंग। द लोड टुवर्ड्स ऑल द वर्चुअल मशीन शुड बी बैलेंस। ऐसा नहीं है कि VM1 को हमने बहुत ज्यादा लोड दे दिया और 2 को कम दिया। दिस इज वन इंपॉर्टेंट फैक्टर। रिस्पॉन्स टाइम वट एवर, आई मीन देखिए, अगर कोई वर्चुअल मशीन ओवरलोडेड है तो रिस्पॉन्स टाइम सर्टनली बढ़ जाएगा। तो वो जो नया टास्क आ रहा है वो उस मशीन पे जाना चाहिए जिस पर कम लोड है, तो रिस्पॉन्स टाइम बढ़ जाएगा। वर्चुअल मशीन माइग्रेशन। देखिए, ये जो टर्म्स है ना, ये आपस में रिलेटेड है। अगर रिसोर्सेज का क्लाउड में, जो क्लाउड डेटा सेंटर है उसमें रिसोर्सेज का इफेक्टिव रिसोर्स यूटिलाइजेशन होगा तो एनर्जी कंजम्पशन कम होगी। मैं इसके बाद एक डायग्राम से ये चीज क्लियर कर दूंगा। बट व्हाट वी हैव टू डू, वी हैव टू डिटेक्ट हॉटस्पॉट एंड द कोल्ड स्पॉट। ये काम होता है लोड बैलेंसर का। अगर हम डिटेक्ट करके VM का माइग्रेशन कर देंगे एक फिजिकल हार्डवेयर से दूसरे हार्डवेयर पर, तो हमारा लोड बैलेंस हो जाएगा, रिस्पॉन्स टाइम बेटर हो जाएगा। बस हमें माइग्रेशन का ध्यान रखना है। एनर्जी कंजप्शन, मैं इस ही पर्टिकुलर, मैंने आपको बताया कि मेन यही है। ये सारे फैक्टर्स इसी की तरफ एट द एंड ऑफ द डे डाइवर्स हो जाते हैं, इसलिए मैं इसी को थोड़ा सा और एक्सप्लोर कर रहा हूं। ट्रिमेंडस एनर्जी कंजप्शन ऑफ क्लाउड डेटा सेंटर्स गिव राइज टू सिग्निफिकेंट चैलेंज फ्रॉम बोथ इकोनॉमिक एज वेल एज environmental perspective. In 2018, a study revealed that the energy consumption of data centers around the world was approximately 1.1 to 1.3% of the worldwide total, and the rate was expected to increase by 8% by 2050. 60% of total energy consumption data center comes from the IT infrastructure, which is dominated by physical machines. See, there are physical machines जिसको मैं ये बताता हूं, ये physical machine है, and ये उस फिजिकल मशीन्स को मैंने वर्चुअली अगर कैटेगराइज कर लिया तो ये वर्चुअल मशीन्स हो जाती हैं। फिजिकल मशीन, जब भी मैं फिजिकल मशीन यूज कर रहा हूं, द अंडरलाइंग हार्डवेयर। Now let us look at this. This is a scene. Let us suppose this is a physical machine 1, 2, 3, 4 and 5. This is an active host 1, 2. Now this active host, there is a virtual machine VM1 which is actually 30% of this using hardware. इस हार्डवेयर का इस एक्टिव होस्ट 1 का 30% कंज्यूम किया जा रहा है इस वर्चुअल मशीन 1 में। ये वर्चुअल मशीन 2 जो इस पर चल रही है वो इस होस्ट का 50% कंज्यूम कर रही है। बल्कि ये जो VM3 है ना, ये सिर्फ 10% कंज्यूम कर रही है। VM4 2% कंज्यूम कर रही है इस हार्डवेयर की एक्चुअल 100% कैपेसिटी का, और ये 70% कंज्यूम हो रहा है ये VM5। अब सबसे इंपॉर्टेंट बात यह है कि ये पांचों मशीनें जो हैं क्लाउड डेटा सेंटर में ये पांचों मशीनें चालू है, ये पांचों मशीनें चालू है, ये पांचों मशीनों को के लिए एनर्जी कंजप्शन हो रहा है, इनको कूलेंट के लिए, इनको कूल करने के लिए भी फिर एक क्या होगा, इनको कूल करने के लिए भी एनर्जी मतलब आपने यहां पे देखा था ना कि कूलिंग एंड पावर प्रोविजनिंग सिस्टम भी एनर्जी कंजप्शन करता है। वी हैव देयर इज अ रिक्वायरमेंट ऑफ कूलेंट्स एज वेल। ओके, तो ये सारे एक्टिव होस्ट है। अब देखिए, सबसे इंपॉर्टेंट बात ये हो जाती है कि अगर मैं इसमें देखूं और यहां पर मैं ये यहां पर 50 यहां पर मेरे पास जैसे 50% है, 50% और VM4 यानी कि इसको उठाकर मैं एक जगह रख दूं, मैं VM3 को इस पर माइग्रेट कर दूं, तो ये 60% हो जाएगा। ओके, दिस इज हाउ इट कुड बी डन। आई मीन हम लोग एक इफेक्टिव माइग्रेशन के हिसाब से, है ना, हम लोग क्या कर सकते हैं, जैसे अगर मैंने इफेक्टिव माइग्रेशन करके एक पर ले आया तो मैं तीन को पावर ऑफ कर पाया, 1 को, 3 को और 4 को, तीनों को मैंने पावर ऑफ कर लिया एक इफेक्टिव माइग्रेशन के हिसाब से। तो उससे क्या हुआ, ये तीनों की जो एनर्जी कंजम्पशन थी वो बच गई। सो इस रिगार्ड में मैं डीएल और ना, दिस इज वन स्लाइड विच इज एक्चुअली टेलिंग कि यहां पर मेरे पास एक फिजिकल मशीन 1 है जिस पर 3 वर्चुअल मशीन चल रही है, फिजिकल मशीन 2 है जिस पर 2 वर्चुअल मशीन आर एग्जीक्यूटिंग, एंड देयर इज अ फिजिकल मशीन 3 ऑन विच ओनली 1 वर्चुअल मशीन इज देयर। नाउ द नेक्स्ट टास्क इज कमिंग, where this next task should go, where should it go to detect this? See, to identify, uh, see, to identify the machine which is overutilized, that is hot spot, and the cold spot is to identify the machine which is underutilized. Okay, so उसके लिए सबसे पहले मैं आपको ये we have actually we have a proposed scheme, a component driven research utilization prediction model. We have used it 3 steps. तो मैं मतलब before walking under to the slides, let me tell you one thing that Google Cluster Trace, it's a data set which is actually publicly available. ओके, ये 29 डेज का डेटा अवेलेबल है जिसमें 12,500 यानी कि 12.5 थाउजेंड मशीन्स का डेटा अवेलेबल। अब ये मशीन्स का जो डेटा अवेलेबल है, ये मशीन्स का डेटा इस तरह से अवेलेबल है कि इसमें जितनी भी वर्चुअल मशीन्स पर टास्क आते हैं, जितने भी वर्चुअल मशीन्स पर टास्क आते हैं, ओके, जैसे कि आप ये देख सकते हैं कि टास्क आया, वर्चुअल मशीन्स तो बन गई, अब एक टास्क आया, अब वो टास्क कौन सी वर्चुअल मशीन को मिलेगा उसकी रिक्वेस्ट है। और हमने बेसिकली ये देखा कि हम किस तरीके से इसकी तरफ अप्रोच करें। तो हमने इसको 3 स्टेप्स में किया है, मैं 1 बाय 1 आपको बताता हूं। देयर इज नो पॉइंट ऑफ आई शुड रीड दिस, लेट मी टेल यू वन थिंग वेरी क्लियरली कि सबसे पहले मैंने 12,500 मशीन जो मेरे पास अवेलेबल थी 29 डेज के डेटा में, सबसे पहले मैंने उसके सीपीयू को देखा, उसके सीपीयू यूटिलाइजेशन को निकाला कि, और ये हम लोगों ने क्या किया था कि सबसे पहले एक ये डेटा प्री प्रोसेसिंग में जिसकी मैं बात आपसे कर रहा था, तो डेटा प्री प्रोसेसिंग के लिए हम लोगों ने एक सम एवरेज एल्गोरिथम प्रपोज की। सम एवरेज एल्गोरिथम को हमने इसलिए प्रपोज किया ताकि जो हमारे पास टास्क की इंफॉर्मेशन है उससे हम क्या कर पाए, उससे हम मतलब ये मान के चलिए कि जैसे ये टास्क 1 है, ये 0 से 30 सेकंड तक चला, और 30 सेकंड से यहां से टास्क 3 आ गया जो कि 55% चल रहा है। अब मैंने इस चंक में निकालने की कोशिश की कि 0 से लेकर 50 सेकंड तक कितना ओवरऑल लोड था मेरे फिजिकल मशीन्स पर। ओके, मेरे पास 12,500 फिजिकल मशीन्स का डेटा अवेलेबल था। तो सबसे पहले मैंने इस कंटेक्स्ट में ये निकालने की कोशिश की कि कितना लोड उस पर्टिकुलर टाइम स्टैम्प में एनीवे है। ओके, और इसके बाद मैंने इस तरीके से बाइफरकेशन की, सम एवरेजिंग का यूज करके इस तरीके से एल्गोरिथम लगाई और इस तरीके से करके निकाला, और ये 5-5 मिनट का डेटा निकाला। वो घंटों का डेटा अवेलेबल था, मैंने उसको 5-5 मिनट का करके 29 डेज में ही निकाला। और उसके बाद हम लोगों का ये हमने ये देखिए, आप मैं आपको डायग्राम आई मीन आई एम गोना एक्सप्लेन विद द हेल्प ऑफ यूजिंग डायग्राम। So we have the Google cluster trade data. We have extract relevant features. There is a task usage table जो बेसिकली लोड के बारे में बात करती है. We have actually extract the features like start time, end time, okay, machine ID, whatever the machine ID was, the mean CPU usage, canonical memory usage, and whatever we have did, उस टास्क यूसेज टेबल से हमने सारा डेटा निकाला. ठीक है, फिर उसके बाद हमने सम एवरेज एल्गोरिथम में दिया. सम एवरेज एल्गोरिथम जो कि हमने ही डिजाइन की थी. और उसके बाद हमारे पास क्या आया? वी हैव मीन सीपीयू यूसेज एंड कैनोनिकल मेमोरी यूसेज. अब min-max normalization is done. Hopkins statistics. See, अब हमारे पास ये जो डेटा था, हमारे पास जो जो ये डेटा था, ये बेसिकली अनसुपरवाइज था. इट वॉज नॉट अ लेबल डेटा, क्योंकि कौन सी मशीन कितना यूज कर रही है. इट इज आई मीन व्हाट टू से, इट इज अ पर्सपेक्टिव इशू कि वो हॉट स्पॉट में है या कोल्ड स्पॉट में है, ओवर यूटिलाइज है या अंडर यूटिलाइज है. तो सबसे पहले मैंने क्या किया कि उस मशीन्स को बेसिकली सबसे पहले ये देखा कि ये जो डेटा है, क्या ये क्लस्टरिंग के लिए अवेलेबल है, सही है कि नहीं है. जिसके लिए देयर इज अ मेथड व्हिच कम्स टू द एक्शन इज हॉपकिंस स्टैटिस्टिक्स. हॉपकिंस स्टैटिस्टिक्स को जब मैंने चेक किया तो द स्कोर वाज 0.5, व्हिच एक्चुअली अगर ये 0.5 से ज्यादा था, अगर नहीं होता तो क्लस्टरिंग इज इनफेक्टिव, बट था, तो मैंने इसका सिलोट स्कोर निकाला, जिससे ये पता चलता है कि कितने क्लस्टर्स बनाए जा सकते हैं. पर जितने क्लस्टर्स बनाए जा सकते थे, मैंने जीएमएम यानी कि गॉसियन मिक्सचर मॉडल, एक क्लस्टरिंग है जिसकी मदद से मैंने क्या किया कि फिर उतने क्लस्टर्स बनाए. और हर क्लस्टर की मैंने मीन और मीडियन मशीन को निकाला. मीन और मीडियन मशीन को निकाला और जिसके ऊपर मैंने मॉडल्स बिल्ड किए जो ये प्रिडिक्ट करते थे. सो इट वाज बेसिकली अ मल्टी मॉडल अप्रोच, बिकॉज फॉर let's suppose I have n number of clusters, but I guess for this we have three clusters actually, and for three clusters what I have done, uh, let us take the things pretty ahead. कि फिर क्या किया मैंने, एक बार जब मेरा आ गया, मैंने ये सारी मीन और मीडियन, हर क्लस्टर के लिए मैंने मीन और मीडियन मशीन निकाली. और उसके बाद मैंने क्या किया कि उसको वापस इनपुट देकर, मतलब उसका पूरा डेटा लेकर सम एवरेज एल्गोरिथम में दिया और 5 मिनट्स के टाइम स्टैम्प पर मैंने मीन सीपीयू से निकाला. और उसके ग्राउंड पे मैंने मॉडल बिल्ड किए और ये सारे मॉडल मैंने चला के देखे आरएमएससी पर. तो हमारा जो मॉडल था, विच वाज एक्चुअली this amalgamation with LSTM, which was giving better results as compared to other things. Okay, this is how the things proceeds. तो आप देख सकते हैं. अच्छा, इसमें आप देखिए, अगर कोई मेरे पास ये सिचुएशन है, लेट सपोज दिस. अगर इस सिचुएशन में मैं प्रिडिक्ट कर पाऊं कि अगली जो आने वाली है, अगला जो मेरे पास रिक्वेस्ट आने वाला है किसी वेंडर से, उसको मैं कहां प्लेस कर सकता हूं, ताकि मिनिमम प्लेसमेंट करना पड़ेगा. देखिए, सबसे ज्यादा एनर्जी जो क्लाउड कंप्यूटिंग में जाती है, जो क्लाउड डेटा सेंटर्स में जाती है, वो वीएम के माइग्रेशन में जाती है. जब मैंने वीएम को यहां से उठा के माइग्रेट किया, तब एक एनर्जी बहुत थी. और ये जो पावर ऑन पड़ी है पांचों सिस्टम की, इसमें एनर्जी बहुत ज्यादा. सो वट एवर यू हैव यूज, मैंने जब उनको माइग्रेट करा के लेकर, मतलब मैं, व्हाट कुड बी द राइट प्लेस टू प्रिडिक्ट the right host where the next virtual machine could be put. इस रिगार्ड में the machine learning algorithms could be used in this context. The end result will be energy consumption, optimize energy. Right, this is how it is. Okay, so this is what a lot of things which we have done. So this was a challenge in GCD dataset, which we figured out sharing of resources between tasks. So we have actually proposed the algorithm, which is most commonly known as sum average, with which we actually figured out, with the help of using task, spreaded, diversified across the time stem, we figured out the over a particular instance, the load over instance on a physical machine. Fine. जिस तरीके से मैं आपको ये एक का दिखा रहा हूं, इसी तरह मैंने 12,500 मशीन्स के लिए स्क्रिप्ट, मतलब एक स्क्रिप्ट लिखी थी पाइथन की, जिससे मैंने 12,500 मशीन्स के लिए पर डेटा निकाला. और उन 12,500 मशीन्स पर मैंने बेसिकली आइडेंटिफाई की, उनको क्लस्टरिंग किया तो वो 3 से 4 क्लस्टर्स में फाइंड आउट की, फिर उन क्लस्टर्स के मीन और मीडियन पर मैंने मॉडल्स बनाए और अपकमिंग रिक्वेस्ट को रिग्रेशन में लगाया कि कहां पर हम लोग वो फॉल कर सकती है, किस एक्टिव होस्ट पे जा सकती है. फाइन. दिस इज हाउ. So we have used first of all LSTM for this. This is the what this was the working of the proposed scheme. तो जैसा मैंने आपको बताया कि यहाँ पर मैंने वर्कलोड ट्रेस, वो 5 मशीनें जो मैंने निकाली, लेट सपोज कि मेरे पास 3 क्लस्टर्स आए, तो 3 क्लस्टर्स के एवज में मैंने 6 मशीन निकाली, मीन और मीडियन मशीन, जिसको मैंने सम एवरेज पर लगाकर फिर मैंने क्या किया कि उन मशीन का मीन रिसोर्स यूसेज निकाला, जीएमएम में डालकर फिर उनके क्लस्टर्स नंबर निकाले कि C0 क्लस्टर्स के लिए देखिए मेरे पास M1 मशीन है और एक मीडियन मशीन है. M1 स्टैंड फॉर द मीन, और मतलब दिस इज हाउ आई कैटेगराइज मीन एंड मीडियन मशीन आईडी फ्रॉम ईच क्लस्टर. फिर उनकी सम एवरेज एल्गोरिथम में डालकर मैंने उनका 5-5 मिनट के टाइम स्टैम्प में इनका निकाला कि मीन रिसोर्स यूसेज हो कितना रहा है. ठीक है. एलएसटीएम के थ्रू फिर हमने उसको प्रेडिक्ट कराया सीपीयू के लिए. बेसिकली सीपीयू के लिए क्यों यूज कराया मैंने? सीपीयू के लिए इसलिए यूज कराया, हम लोग इस स्लाइड से देख सकते हैं कि सबसे ज्यादा एक जो है सर्वर्स ही यूज करते हैं, इसलिए जो मेजोरिटी है वो सीपीयू की वजह से ही होता है. ओके. तो यहाँ हमने क्या किया, इस तरीके से निकाला था कि हमने क्लस्टर्स लिए, टोटल मशीन जी 12,500 मशीन थी हमारी, तो हम देख सकते हैं हमने कुछ 4 क्लस्टर्स निकाले थे और हर एक क्लस्टर में से टोटल मशीन इस क्लस्टर में इतनी आ रही थी जिसमें हमने मीन मशीन और मीडियन मशीन निकाली और इस मशीन पर हमने अपने मॉडल को प्रिपेयर किया और जिसमें हमने देखा कि इट वॉज परफॉर्मिंग वेरी वेल एज कंपेयर टू, इट वॉज अ टाइम सीरीज डेटा, जो 5-5 मिनट का डेटा हमने निकाला था, इट वॉज परफॉर्मिंग वेरी वेल अदर टाइम सीरीज एज कंपेयर टू अदर टाइम सीरीज लाइक अरीमा एज वेल. एक्यूरेसी इसकी काफी अच्छी आ रही थी. सो इस चीज को मैं आपको एक बात बताना चाहता था कि इसको मैंने एक इट वॉज अ वर्क विच वी हैव डिड, और फिर इसी काम को हमने, देखिए इसी काम को हमने आगे बढ़ाया, जिसमें हमने इनकी हेट्रोजेनिटी को भी कंसिडर किया. हेट्रोजेनिटी को कंसिडर करने का मतलब यह है कि क्लाउड डेटा सेंटर्स में 12,500 मशीनें थी. हर मशीन का अपना एक मतलब हार्डवेयर होता है, यानी कि हर मशीन के अपने सीपीयू रिसोर्सेज होते हैं, अपनी कैनोनिकल मेमोरी होती है, रैम होती है. ठीक है. इस तरीके से अब उस चीजों को मतलब टू ब्रिंग दैट ऑल द थिंग, नाउ व्हाट वी हैव डिड इन द फर्स्ट, मैंने आपको अपना स्ट्रक्चर बताया, उसी काम को मैंने जब एक्सटेंड कराया, उसी काम को मैंने एक्सटेंड कराया. सी एलएसटीएम जो है, एलएसटीएम इज अ टाइप ऑफ रिकरेंट न्यूरल नेटवर्क डिजाइन टू हैंडल सीक्वेंशियल डेटा, especially sequential data. It faces the problem of vanishing gradient. इसमें लॉन्ग टर्म डिपेंडेंसी को किया जाता है, एनकाउंटर किया जाता है. ठीक है. पर there is another technique which is called transformers. Transformers are better than LSTM in several ways. सबसे पहले इंपॉर्टेंट आती है बात की पैरेलल प्रोसेसिंग की. ट्रांसफॉर्मर प्रोसेस entire sequence simultaneously using self attention, making them significantly faster than LSTM, which process sequential. लॉन्ग रेंज डिपेंडेंसी सबसे इंपॉर्टेंट फैक्टर जो मैं ट्रांसफॉर्मर की बात करता हूं. देखिए ये जो ट्रांसफॉर्मर है या हम इन्फॉर्मर की बात करते हैं, ये ट्रांसफॉर्मर और इन्फॉर्मर बेसिकली इट वाज अ टेक्निक ऑफ एनएलपी which is actually adapted for regression and the classification as well. Fine. So this is how the things goes on. Long range dependency, transformers efficiently capture relationships. Sorry, transformers efficiently capture करता है relationship across long sequences without the vanishing gradient problem that can affect LSTM. जहां तक हम शॉर्ट टर्म डिपेंडेंसीज की बात कर लेते हैं, एलएसटीएम अच्छी तरह कैप्चर कर लेता है, बट इट वाज एक्सपेरिमेंटली प्रूवन दैट अगर जब हम लॉन्ग रेंज डिपेंडेंसीज की बात करते हैं तो ट्रांसफॉर्मर्स प्रूव आउट टू बी आउट परफॉर्म द एलएसटी. स्केलेबिलिटी, दिस इज वन ऑफ द इंपॉर्टेंट फैक्टर. ट्रांसफॉर्मर्स हैंडल करता है लार्जर डेटा सेट्स एंड मॉडल्स बेटर ड्यू टू देयर आर्किटेक्चर विच इज ऑप्टिमाइज्ड फॉर मॉडर्न हार्डवेयर. ओके, दिस इज हाउ वी, तो हमने अलग टेक्निक का यूज किया, बिट्स का, अलोंग विद द ट्रांसफॉर्मर एंड इन्फॉर्मर मॉडल। मतलब इसमें हम लोगों ने बिट्स क्लस्टरिंग लगाई थी, हमने वही सब कुछ किया, सम एवरेज एल्गोरिथम एंड जेनिस्को नॉर्मलाइजेशन, एवरीथिंग विच वी हैव डिड। अब हमने बिट्स क्लस्टरिंग लगाई। बिट्स क्लस्टरिंग से हमने निकाला कि हमें कितने क्लस्टर्स की जरूरत है, और उसके बाद तीन आर्किटेक्चर्स हमने उसमें कवर किए, जिसमें एलएसटीएम, ट्रांसफॉर्मर एंड इन्फॉर्मर मॉडल से। एंड विद अ रिगरस एक्सपेरिमेंटेशन वी फिगर आउट, सी, अच्छा, इसमें मैं आपको एक चीज और मैं बताना चाहूंगा कि हम लोगों ने जब बेसिकली बिट्स क्लस्टरिंग लगाई, सो लास्ट टाइम हम लोगों ने दो ही पैरामीटर कंसिडर किए थे, द फर्स्ट सीपीयू यूसेज एंड द मेमोरी यूसेज। इसमें हमने बेसिकली तीनों पैरामीटर यूज किए, उसके बाद हमने बेसिकली क्लस्टरिंग लगाई। So this is what we have done so far with the. I mean, this is a perfect. I mean, energy consumption basically is one of the important artifact or important challenge where the ML and DM could find its venue in order to solve those problems. Okay, we have seen a lot of places where IoT join hands with the ML and the explainable AI in order to assist doctors and solve the problem of patients as well. And this is a particular aspect where in with the cloud, the ML and DML could come into the action. Just a minute. Okay, so broadly, if I wish to summarize, like what we have did, we have actually seen a lot of applications. We have seen the basics of ML and DL, which falls under basically under the category of classification and the regression as well. And down the line, we have seen the prominent applications of it, and we have took the deep dive into the cloud computing and its applications. Where what are the problems in cloud which could be prominently solved with the help of regression as right. So that's all my submission was. Thank you so much for giving me the opportunity. So this is, I mean, the problem is that we, as you can see, I'm actually, we have submitted this paper and patent as well. So I can't speak more on this, but it's a wonderful thing. I mean, I would have, in the near future, if I get an opportunity, I would love to speak about it, that how we planned this. And it actually, uh, giving the end product is very good. Let me tell you one thing very clearly. The end product is very good. We have submitted this all work of an year for the patenting and the paper as well. So that's the problem. I can't speak more on this, but it's a wonderful thing. If in the near future I get an opportunity to speak, so I would love to speak on this. So thank you so much, everyone, for giving me the opportunity to speak.
Thank you very much, sir. If you have any question, you can ask questions. I think there is no question, sir. Thank you very much for joining this session.
Thank you so much.
I'm closing this session.
Hmm.
You
Thank you.
can leave now, sir.